Hey, welcome students. In this video I want to go ahead and talk to you about decomposition reactions. And so decomposition reactions are those types of reactions that involve the following general formula. And so essentially you're going to be taking some compound AB and you're going to break it apart into two parts, either part A and part B. And so the two examples I'm going to show you for this video are essentially going to show you how we take a compound and break it up into various parts. The first example is fairly easy, but the second one's going to involve a little bit more work on our part. So let's go ahead and look at this very first one. It's going to be an easy one. And so we'll look at this. We'll take CaCO3, which is calcium carbonate, and we're going to go ahead and break this apart using a little bit of heat. And that'll form calcium oxide plus carbon dioxide. And so go ahead and start by dividing up your left and right. And then we'll start by first looking at the first atom. So you've got your calcium, and your calcium there, you've got two of them, one on the left, one on the right. So our calciums are balanced in the sense that we've got the same number of calciums on the left as we do calciums on the right. So we can go on to the next atom. That atom there is going to be your carbons. Notice that we've got one carbon on the left and one carbon on the right. And that's all that's left now is to look at our oxygens. On the left-hand side, we notice that we've got 3 oxygens, and on the right-hand side, we've got 1 oxygen bound to calcium, but we've got 2 oxygens bound to carbon. That gives us a total of 3. So right off the bat, what we notice is that we have an equation here that is completely balanced. So there's really not much for us to do except here is to go ahead and to count our various parts. And so here we've got one compound, so that'll give us a coefficient of a 1. And on the right hand side we've got one calcium oxide, so that'll give us a coefficient of 1. And we've got one carbon dioxide, which will also give us a coefficient of 1. If this was a multiple choice test or multiple choice quiz, what you want to do is you want to go ahead and find the answer or the choice either from whatever amount of options you've got. Look for the choice that gives you the following: 1, 1, 1. And looking at from previous videos, this first one relates to the first mole number or the first coefficient. The second one relates to the second coefficient, and the third one relates to the third coefficient in this sample problem. Now this one was pretty easy for us to do, but let's go ahead and look at a little bit more complicated one that is going to require us to do a little bit more balancing. So for this problem, what we're going to do is we're going to take this equation here that we've got. We're going to take KClO3, and we're going to go ahead and react this or apply this to a substance, which is what we call KCl, is what we're going to get, plus oxygen. Now we are mixing this in a solution of manganese oxide, which is MnO2, with a little bit of heat, and that's what that represents there. But essentially what we're paying attention to is the KClO3 on the left-hand side. Okay, here's the left, here's the right, and we're going to see the products KCl and oxygen on the right. And what our goal today is just to simply balance it. So we'll begin with the first atom, and that's going to be the calcium on the left-hand side. So we look on the right-hand side and we notice that we have 1 calcium. So our calciums are balanced because we have the same number on the left as we do on the right. We then move on to our chlorines. We've got 1 chlorine on the left, and we look on the right-hand side and we notice that we've got 1 chlorine as well. So far so good. Everything is balanced. We've got the same number of potassiums. We've got the same number of chlorines. We now turn our attention to the oxygens. And if you notice on the left-hand side, you've got 3 oxygens on the left, and on the right-hand side, you've got 2. Now, at this point, what we want to do is we want to focus on this 3, and we want to make sure that we can convert this into an even number. The easiest way for us to do that is to add another whole compound of KClO3. Now, if we look at the oxygens at this point, you're going to notice that we've got a total of 6. Which means that on the oxygens on the right-hand side, we need to add another oxygen molecule, and another oxygen molecule, pardon me again, for a total of 6 oxygens here on the right-hand side. Okay, so we can see that here. There's 1, 2, 4, and 6. So we've got 6 oxygens on the right-hand side. We've got 6 oxygens on the left-hand side. And so now we turn our attention to the potassiums at the very beginning, because we noticed when we added that potassium ClO3 on the left-hand side, what happened is we added another chlorine and we added another potassium. So we'll go ahead and address this right away. We've got 2 potassiums on the left-hand side, which means we're going to have to add another potassium and a chlorine compound. And by doing that, we also solve the problem that we have with our chlorine. So we have 2 chlorines on the left, as well as 2 chlorines on the right. And we have 2 potassiums on the left, as well as 2 potassiums on the right. So now our reaction here is completely balanced, and all we have to do now is add up all the different compounds that we've got, or the different molecules. So here's 1, 2, so that means our coefficient for this section is going to be 2. We go to the right-hand side, and we've got 1, 2, and that means our coefficient here is going to be 2. And for the oxygens, we've got 1, 2, 3 molecules, and so that means that our coefficient is going to be 3. And if this was a multiple choice problem, you would look for the answer choice that gave you the coefficient numbers of 2, 2, and 3. Otherwise, you would look for the coefficients written inside the actual chemical reaction with 2, 2, and 3. All right, so here is how we identify decomposition reactions and how we go about balancing them.